Suppose we have a function that draws a line like this between x-axis and y-axis, and this line, and we want to know at this particular point how fast or slow this function is changing. So we want to calculate its slope. So its slope will tell us rate of change of something, so whichever it is, the function. So how can we calculate the slope? We can calculate its slope by the change in y direction divided by the change in x direction. Okay, we can also write, so we suppose we have a function that is, we have a function that that changes its y-axis according to the change in the x-axis. So uh, we have we have function is x, and the next stage is, if we change our x by some small quantity del x, then we subtract it, we get our change, and then divided by the change in x-axis, we will get our slope. And this and the derivative of at this point means that uh, if we put if we take if we if the our small element, this small change in which we added into x, if this tends to 0, meaning that this is very small or infinitesimally small, then we get this function, and this is called as derivative. And this is the first derivative of the function, so it's the first derivative. Now so derivative of function y with respect to x gives us slope of a function, so which needs to be continuous and within domain. So if we have a function, so if we have a function like this, so this is a continuous function which starts at this point and ends at this point. Okay, so this range, this is our domain. So this is domain, meaning that this is the all the points. If you take an example, suppose this is time, so its time will be something like 0 plus t to something like 0 plus t to some change. So if this is t1, so its domain will be t from t1 to t2, and its range is from this point to this point. So the values it obtains, suppose this is 5 and this is 15, so its range will be 5, between 5 and 15. Okay, then uh, if we take a second derivative and determine its slope of a function, slope of a function, meaning that, suppose if we zoom into very close, suppose if we choose, suppose if we take this, and if we take this, this is the slope which we are talking about. Okay, this is del x and this is del y. If we again take its slope at this point, at this very point, then this point will tell us its slope. So at this very point, meaning that we first take a derivative, then again we took a derivative at this particular time. So then this let's say this line slope will be our second derivative. Okay, second derivative of this complete line, and this will also tell its slope. Then why are we differentiating? Suppose we have a projectile, we throw a projectile, it creates this shape. Okay, now at we want to know where it reaches its maximum height, so we can calculate its slope. We can calculate its slope at every point. Okay, we can calculate its different, we can differentiate the function, and it will tell us the slope at every point on this function. So how, so if at some particular point we get the function which is equals to 0. Okay, if we put the x-axis into the function, then the resultant will be 0, so this will get us the maximum. So if the slope is equals to 0, then it gives us the maximum height. Okay, maximum height. But what if there is, what if the function is not something simple like this or this or this, these are very simple function, but something like, so something the function looks like something like this. uh, so now it has a local maxima and a local minima. It has 2 points where the curves, where the slope is 0. So to test this thing, we have to take its second derivative. We have to take its second derivative, and that will tell us this, that at this point, this point, at this point, if the slope is 0, then this is a maxima, and if the slope at this point is 0, then this will tell us its minima. Okay, so this is the test. If slope is less than 0, it's local maxima. If slope is greater than 0, it's local minima. Okay, so and there is a concept of positive slope and negative slope. So if for this point this is a positive slope and this is a negative slope, okay,